Okay, so very good afternoon, everyone. And this is the course named Geotechnical Engineering 2. And we are in the week 2 of this course. We are studying Geotechnical Engineering 2, which is taught by Professor D.N. Singh sir from IIT Bombay. Okay, before starting, first of all, I introduce myself. If you are attend the previous lecture or maybe going through the YouTube video links, you are aware about me. But once again, I will introduce myself. Okay. So my name is Sumit Kumar. I am PMRF research scholar at IIT ISM Dhanbad. In this session, I am going to take the Geotechnical Engineering 2 class, and this class is going to take place for 12 weeks, and one more additional week may also I can take, which may be a revision class in which I will revise the entire concepts and take the most important question, which may be which types of question may be asked during your exams, which are going to take place at the end of the course. Okay, so very welcome everyone. So before starting, I will also want to add some points regarding the instructions which going to take place during the coursework. So the basic instructions are you have always need to be joined in this class if due to any circumstances due to internet disconnection or maybe electricity shutdowns due to any problem if I get disconnected at any point of time, be patient and remain in the meeting. I will rejoin and start the class from the same point without any loss. Okay. And two more points I will want to add on over here, the content which I am providing you at this point of time, or in the all of the 12 class, upcoming class and the previous class is shared with you through the Google folder link, which I have shared already. So NPTEL team will provide you those links through which you can go through and you will able to find these presentations files as well, apart from what are the content over there in the website of the NPTEL. Okay. And the video which I am, the presentation which I am giving and the content which I am going to tout in this class or in the upcoming class as well will also be there on the YouTube, and link will be provided to you by the NPTEL team. So I will suggest you to, if some of you are not able to attend in the live, you can go over there. And I will also have a small request. This session is interactive session, so you can ask your question. Yeah, but you can ask the question. You can text me in the chat box over here. The chat box is open for all, and if I will try to answer all the question, all the query, whatever you have during the class, and on the basis of that, we can move forward. Okay. Apart from that, if any doubts will be there from the previous class, we can cover it in the subsequent classes as well. Okay, I think so. The instructions part is very much clear to all of you. So now I will start the class. So before starting the new session, I will want to revise you what I have taught during the previous class in a very quick manner. Okay, I think so that will be more fine for everyone, because small revision will be there. So whatever we studied, I will revise it in the 5 minutes and then we move forward. Okay, so what is the shear strength of soil? We have understood why the shear strength. So we have understood that the shear strength is the ability of soil mass to resist the shear forces. And this is a measure of resistance to deformation or the failure when subjected to shear force or the shear stress. So the shear strength is an important property in the geotechnical engineering. We also understood by the parameter on which the shear strength depends, like cohesion, angle of internal friction, and how they uh, give the strength to the soil is also understood by us during our previous session. We understood we come to know about the some names like triaxial test, direct shear test, some more tests box test, and many more tests and then shear test. Those tests we will come across during this class and in the subsequent class as well, because for the this week and next week we are covering those tests and then we move forward. Okay. Apart from that, what we have understood the importance of studying this topic, importance of studying the shear strength, because during the first session I have said that whatever we study must have some purpose, must have some understanding that why we are studying. Is there any importance of studying those things, or because from our childhood, whatever we are doing, we always ask questions. As a child, we have a think process to ask the question on everything and anything whatever we see, but as we grew up we forget that habit of asking question. But whether you are studying or whether you are doing anything, you have to ask yourself as well, what is the importance, why, what and why are the most important perspective one need to ask during their study or any works in, if you are in the organization, anything you are doing. So what and why is some of the most important thing one need to ask to yourself in order to reach at the solid conclusion. Okay, so that's the not the part of syllabus I have add on. So we have understood the importance. Apart from that, we have understood the shear strength in the granular soil, that is the sandy soil, how it's how in the sandy soil, in granular soil, how it's provide the strength. And in addition to that, we also understood in the cohesive soil how the intermolecular force of attraction or how the excessive loading impact the shear strength in that type of soil. Okay, so we will see about those things as well during our test, like the right shear test and the triaxial test. Apart from that, we have understood about the factors like the state of stresses in soil, that is the normal stress, shear stress, and the interrelation like shear strength equal to C plus sigma and tan phi. After moving from here, we go across the some of the important things uh, like Mohr circle, and the Mohr circle is the one of the most important thing. So we understood the state of stresses like the maximum principal stress, minimum principal stress we have understood, and on the basis of that we have gone across, we have developed the understanding that how the Mohr circle problem solved. And I also have given you some problems during our last class, I think which you have gone across. So you get the better understanding. And when I say this, those people who have gone through the YouTube and or maybe who are going through the YouTube at this point of time, you need to understand that solving the problem by yourself, by your hand, is very much important when you are in developing a understanding about any topic. Because if you have a command on theory, you are not solving it, and solving the numerical problems, the practical implementation, you are not able to achieve the develop the understanding. So, okay, we have talked about these things. We have talked about the triaxial state of stress. We have understood that how we combine. Actually, the factor takes place in the field is the 3D, but we are how we are taking it as the 2D and solve the problems through the Mohr circle. What is the principal, maximum principal shear stress, minimum shear stress we have understood, and the interrelation to find the shear strength and normal strength is also understood by us. Apart from that, we have seen and the property of Mohr circle and the sign convention to understand the Mohr circle. Moving forward, we have developed a generalized solution in Mohr circle analysis. What is the principal, major principal shear stress and minor principal shear stress is understood by us. And afterwards, through this diagram, which is over here, you understood that how. in a Mohr circle, we are able to find the major and minor principal stress. And what do we mean by that? What do we mean by the zero shear plane? And how we are able to find the radius of the Mohr circle? All these things are covered here in very detail during the previous class. And up to this, I want to revise you the concepts. Apart from that, the interrelation to find the maximum principal stress and the minimum principal stress is also presented, and the angle formed between them or the plane at which it is occurring from the current plane is also found through this Mohr circle. So we have understood those concepts, and now we will move forward to our next concept which we are discussing right now. Okay, I think so. Up to here, everything is clear for everyone. Okay, I feel there will be no problem in anyone's mind. I think so. Okay. See, so we are talking about the Mohr-Coulomb failure criteria. In the last class, at the end, we are talked about this thing as well. We have talked that the shear strength is a function of normal stress, that is sigma. And how we have calculated sigma, we found in the previous class. So when the cohesion and angle of internal friction is known to us, we will calculate the shear strength as the C, that is cohesion, plus sigma tan phi, where phi is the angle of internal friction. So, with the help of this interrelation, we reach to understood that what will be the shear stress on the failure plane. So, the interrelation presenting S equal to C plus sigma and tan phi, where C is the cohesion and sigma n is the normal stress and phi is the angle of internal friction, giving the shear stress at the failure plane. We will talk about this interrelation very often at many point of time as we move forward. Okay, now understand through this diagram that what we want to convey. As you see over here, the diagram has been showing, and the normal pressure is presented on the horizontal axis, that is the x-axis, while the shear strength is presented on the y-axis, that is the vertical axis. Over here you can see that intercept of C is over there on the y-axis, and there is angle phi has been formed with the horizontal axis. So this diagram represents the previous interrelation which we have shown, which is also presented over here as S equal to C plus sigma dash tan phi. So over here you can understood that C, the intercept which is made on the vertical axis, is the cohesion of the soil, and the phi, which is the angle of internal friction, that is the angle which is made with the horizontal axis, that is the normal pressure axis, is the angle of internal friction. And when we calculate S equal to C plus sigma tan phi, so we will find the shear stresses. Over here, the sigma dash is the effective stress and sigma is the total stress. So you need to understand the difference between the total stress and effective stress. So suppose I will explain this term as well, because you have, I feel when you go through the course of geotechnical engineering one earlier, you must have the basic understanding of this term. But for a convenient, I will start it from basic and I will explain you that what do is the difference between the total stress and effective stress. And a pore water pressure term is also over here, so I will cover it as well at this point of time only. Okay, so understand. Suppose there is a layer of soil which has the thickness edge of this edge of this my hand. Okay, so you understood that suppose the water table is lie up to top of my hand as my hand position shown on in the horizontal direction. So you can see that as the water table is up to top of this point, so there is when we calculate the total stress, so the gamma saturated in multiplied by this depth is the value of total stress. because I feel you have a basic understanding. So the gamma saturated into this test will be the total stress. But when we talk about effective stress, we remove the pore water pressure which is created due to water. So the total stress is the gamma saturated into this depth. Suppose this depth is h. So gamma saturated into h is the total stress. When we talk about the effective stress, that will be the gamma saturated into h minus gamma w into h. That is, we subtract the pore water pressure, that is the uh, density of water or unit weight of water over here we say, multiplied by the value of depth is said to be pore water pressure. So when we subtract the pore water pressure from the total stress will be the effective stress. Now there is a one question arises. What are the regions? As we know, as you might be known earlier that the if we calculate perform the analysis on the basis of total stresses. Okay, so you ignore basically there might be some chances that it not be remain saturated throughout its life. At some point of time it may be saturated, at other point of time it may not be saturated. That's why we have to calculate the effective stress parameter, that is the C dash and phi dash, and we have to consider the sigma dash value, that is the effective stress for the calculation of shear stress acting on a plane. Because if we ignore these terms, the water is the biggest problem from soil. Because if you have gone through the soil mechanics, you have understood that if the water table get dry, the strength may be reduced by half of the time, approximately half of the time. If water table is at the ground level, then we calculate the gamma w into h, it will become a if we then we calculate the effective stress, it will be half, and if the water table is not there, it will be two times approximately, not I'm saying in the exact. Okay, so the water is the one of the biggest problems, so we that's why we consider the effective stress over the total stress, and the effective stress is the total stress minus pore water pressure. Okay, I think so up to this point everything is clear. Okay, so we'll move forward. Give me a minute. I will take some water. Okay, we'll move ahead. Okay, see. Now we will talk about the some key concepts. I have talked about some key concept in the previous class, so I will take that over here. Then move ahead. So we have talked about the shear strength of soil. So the key concept is like the shear strength, effective friction angle, what is meant by cohesion, what is meant by apparent cohesion. So I will give a one-line definition for everything, and that will be there in the presentation which will be shared with you. So I will give one-line definition and then move ahead. Okay, I think so. I am audible. Yes. Okay. I have checked it by myself. Okay, the shear strength of a soil is the maximum internal resistance to be applied shearing force. So, oh, that is the shear strength, and the shear definition of shear strength has been taken from the earlier. So, I don't think it need to be defined again and again. Just one line definition. I will read. I will tell to you and move ahead. So, effective friction angle is a measure of shear strength of soil due to friction, and if the strength is there, there is a bonding between the soil molecules, soil particles. So it's maybe the cementation, maybe it's happened due to cohesion, maybe it's happened due to angle of internal friction, but mostly due to cohesion. So cementation is a measure of shear strength of soil forces that the particles attain due to its interaction. When we talk about cohesion, it is the measure of intermolecular forces because from earlier from the previous classes we know that the cohesion strength which is present there due to cohesion is due to the intermolecular force of attraction, while when we talk about the apparent cohesion, it is the apparent shear strength at the zero normal effective stress that is due to only due to cohesion. So when we talk about there is a state called the critical state, we also know about the critical state file mechanism that is not the part of our syllabus. If at any point of time it's came, I will discuss little bit, but that's not the part. Just for a definition, I will say you that a critical state is a state of reached in the soil when the continuous shearing process occurs at the constant shear stress to the normal effective stress ratio and the constant volume at constant volume. Sorry. Okay, dilation. The dilation is, as the name suggests, the change in volume. So it is a measure of change in volume of soil when the soil is dilated by shearing. So the dilation, whenever if you have gone across any software packages, you have seen that they ask the value of cohesion, friction angle, modulus of elasticity, Poisson ratio, and apart from that, they also ask about the dilation angle. So this is the dilation that its change in volume capacity is how much, how it's affect the soil in one way or the other. So that factor is one of the most important thing which are over there. Okay. So I think so to here everything is clear. Okay. Now we move to the next slide, and you can see in this slide there is a simple term written over here. That is the shear strength definition. So, we define the shear strength as a material response when subjected to shearing motion because there is strength with the soil, but it give it come as a response when we apply a stress over there. So, the shear strength as a material response when subjected to shearing motion, and the retreat concept of shear motion and the detachment along a plane. It is a concept of a weak plane and is significant in the shearing behavior, and mathematical definition when we say about a weak plane, the shear stress applied is above than the critical shear strength, then it will lead to its then it will lead to the failure along that plane. Now we talk about the factors. There might be some factor which is one of the key aspects due to which the failure takes place across any plane or the other. So what are those factors? You need to know, yes or not? Yes. So we talk about the factors. Okay. So the major factors causing the shearing is the one of the factor is earthquake. Now there are many factors, but one of the earthquake is because in the earthquake also the shear strength got disturbs. We talk about the liquefactions over there also the shear strength get reduced from the value which need to be have. So the major factor, so the major factors causing the shearing is the earthquake, and earthquake can lead to the relative motion between the soil layer, and if the relative motion is there, there must be the stress which has been applied on the plane is more than the strength of the soil at that plane. And a fault causing one portion of ground to slip down leading to the shearing is the thing which takes place during the earth. And understanding the state of stress during the shearing is one of the crucial stability assessment. Some other factor that can also lead to the shearing of soil is the slope instability and some construction activity. As we have seen that if some construction activity maybe go at any place, it may sometime also sorry, it may sometimes also lead to the some reduction in the shear strength in one way or the other. We talk about those things in the upcoming classes. Now we talk about some of the applications and its significances. What are the applications which are over there? So talking about the applications, the engineering significance of understanding the shear strength in the geotechnical projects and the shear strength analysis help in designing foundation, retaining wall and slopes. The role of shear strength is most important in accessing the stability of the natural and the man-made structure. Now, when we talk about the natural and man-made structure, when we say these things, we talk about the human activity like the construction and expansion can alter the state of stress in the soil mass, and that will lead to a problem at that places. We also talk about the incremental changes in stress can lead to the shearing, especially along the weak plane. So its significance is also very high. We talk about the shear strength of soils. When we are talking about the shear strength of soil, we say that the soil consists of the individual particles that can slide and roll relative to one another, and the shear strength of soil is equal to the maximum value of shear stress that can be mobilized within a soil mass without failure taking place. The shear strength of soil is a function of stresses applied to it as well as the manner in which the stresses are applied. The knowledge of shear strength of soil is necessary to determine the bearing capacity of the foundation, the lateral pressure extended on the retaining wall, and the stability of slopes. As I have discussed this point in the previous class as well, that the shear strength is the most important factor before moving ahead with any construction work. Either that work is going on the any site, maybe that construction work, maybe development of any infrastructure projects, maybe construction of any institutional building or any residential building. Before that, the soil report is very much important, and the soil report consists of the parameters like the cohesion and angle of internal friction. Also in it, which we are talking about, on the basis of that we determine the strength over there. On the basis of that we are able to tell that this much load the soil can sustain, and if we need above that we need to improve the soil for that condition by replacing the existing soil over that site from the new soil, or maybe some improvement in the soil need to be provided in order to sustain that much load which we want to apply at that site. And it is valid for all the projects like the road construction, railway construction, or any other construction. So it is one of the most important factors. When we have talked about the Mohr circle in the previous classes. So in the soil testing, the cyclic cylindrical samples are commonly used in which the radial and axial stress act on a principal planes, and the vertical plane is usually the major principal plane, whereas the horizontal plane is a major principal. When we talk about the radial stress, its representation is sigma r is a minor principal stress, or and the which is also said to be sigma 3, and the axial stress sigma a is the major principal stress which is also said to be sigma 1. Okay, so over here, now I will show you one of the images from which you can see that over here the axial stress is sigma A. In this case, is the major principal stress, and the sigma 3, that is the radial, is sigma R, which is represented by is the minor principal stress. And over here you can also see some of the theta angle. Just for one of the small clarity, I have shown this image to you. Now I will talk about the Mohr-Coulomb failure criteria. There must be the some criteria due to which the failure takes place. And what is that criteria we are going to discuss over here? Okay, see, when the soil sample has failed, the shear stress on the failure planes define the shear strength of the soil. As we have discussed during our previous session as well, that the soil has some strength and it fails when the stress apply on that section bypass that value. So how we come to know? Now it get bypasses that value which it can able to hold. So there is a very simple example of that. Suppose soil section. Suppose a simple example is like you can see this box. This box is visible to you? I think so. So this box has strength to bear a load of 100 kilonewton when we apply on it after the application of 100 kilonewton it will move. So its strength is 100 kilonewton. The value up to 99.99 kilonewton it can resist up to 100 kilonewton, but if we apply the load 100.01 as well, it will not able to resist that much force and it will start moving in this direction. So you need to understand by this a simple one term definition, you can say one term explanation, that when the soil sample has failed, the shear stress on the failure planes define the shear strength of the soil, because at the failure the stress which are acting is the strength of the soil, because after that what much stresses is applied is showing the failure. You may be seen at some point of time the various graphs, it is moving almost linearly or non-linearly up to some point, and afterwards it's get horizontal, and the dead line the horizontal line so that the failure takes place from here, so that's why it is moving in one direction only without any increase in the stresses. So that is the failure plane, and the stress acting at that point is the shear strength of the soil at that plane section. Okay, so it is necessary to identify the failure plane, whether it is possible that the plane on which the maximum shear stress act, or is it the plane where the ratio of shear stress to normal stress is maximum. So for here, it can be assumed, for now we can assume that the failure plane exists and it is possible to apply the principal stress and measure them in the laboratory by conducting the triaxial test. We have talked about the triaxial test in the previous classes as well. So what is the triaxial test we are going to discuss in this class as well, but in more detail in the subsequent class, like in the next class. But a little bit we will touch about the triaxial test in this class as well. Okay. Now you can see that the Mohr circle of the stress failure of the sample can be drawn using the known value of principal stress. As we know, if we know the value of sigma 1, sigma 3, we can found the coordinate, center coordinate, radius like the sigma 1 minus sigma 3 by 2, and that is the value of the maximum shear stress. We can plot that section on the horizontal axis. We have seen in the previous class in the four problems over there, we also found that there is a zero radius Mohr circle get also formed on the x-axis, on the positive x and the negative x-axis. We have also seen that a Mohr circle get formed in which the center is coordinate is 0 0 and the radius of sigma. So we have seen everything. So you can see if the data from the several tests is carried out on a different samples up to failure is available, a series of Mohr circle can be plotted. We will see that the three Mohr circle we will plot, and on the basis of that sigma 1, sigma 2, sigma 3 can be found, and it is the conveyance meant to show only the upper half of the Mohr circle because it is symmetry about the x-axis, and a line tangent to the Mohr circle can be drawn, each called to be Mohr-Coulomb failure envelope. And what do we mean by the Mohr-Coulomb failure envelope? You can see from this image, which is visible on your screen right now. You can see that the Mohr-Coulomb failure envelope get formed over here. The three Mohr circle is there. So in this case, there is only change when we discuss Mohr circle in detail. We will see that the value of sigma 3 get increased from one place to one other place, and the value of sigma 1 is known on the basis of that. As we know, the deviatric stress is applied from the vertical direction, and the deviatric stress is nothing but the sigma 1 minus sigma 3. So you can able to find the value of sigma 1 on the basis of as we apply the sigma 3, and after changing the sigma 3 to another value, the value of sigma 1 also gets changed. When we find the sum of the Mohr circle, we draw a common tangent to that, and over here you can see the intercept on the y-axis is the value of the cohesion, and the angle which it made with the horizontal axis is the value of the angle of internal friction. On the basis of this, also we can find the value of the C and phi. Okay, up to here everything is clear for everyone, I think so. Now we will move ahead in the same direction, and we will see. Sorry. Okay, excuse me for a minute. Okay, now see. Now see, we are talking about the Mohr-Coulomb failure criteria, and you have seen all the diagrams as you can see right away on your screen. So, if the stress condition for any other soil sample is represented by the Mohr circle that lies below the failure envelope, every plane within the sample experiences a shear stress which is smaller than the shear strength of the sample. Thus, the point of tangency of the envelope of the Mohr circle at failure gives the clue to the determination of the inclination of failure plane. As I have explained over here, you can see the value of the intercept on the y-axis is the cohesion, and the angle which it made with the horizontal axis, that is the sigma axis, is the value of angle of internal friction. You can see it again from this image. You can see over here the value of the friction angle is also represented as phi, and C on the value on the tau axis, the intercept over here it cut is the cohesion, and the value of sigma 3 and sigma 1 is also presented. Okay. Now we will talk about the different type of test which we are going across in when we move ahead in our direction. So different type of test on the for the shear strength is performed. What are those tests? One of the most important question that what are the tests we are going to perform to find the shear strength? So some of the most common test is like the shear box test, that is nothing but the direct shear test. The triaxial test is the one of the most important test, but it takes some time and require patience and some little bit expertise as well for performing that, because the Scampton parameter we need to understand before making our sample. So this is also one of the tricky tests. The another test is the Vein shear test. Apart from that, these three tests are the most famous tests which one perform, but mostly the direct shear test and the triaxial test is performed. Apart from that, the Todd shear test, flag shear test, and the penetration tests are there. We will going to discuss the first three tests in detail, and rest of the tests are just for the information. One line definition we will discuss over here for the one and all test, and afterwards we will move ahead, and in the end of the today by the end of the today class and in the coming class ahead, we are going to discuss the first three tests in the very detail that how it's possible, what are the interrelation we are going to develop, and how we will able to achieve the shear strength parameter from those tests in our able to find the shear strength of the soil. Okay. So first of all, talk about shear box test. It is direct shear test. In this test, the shear box test, the 2D simulation of soil condition, it provides a plane strain or the plane stress representations of the shearing behavior. It has a limitation in replicating the real world 3D condition because there is a already predefined failure plane is also there in this test. So that is also one of the big limitation. When we talk about the triaxial test, it is a 3D test because the stress are applied from the all directions. As you say, over here the cylindrical specimen gets formed in a membrane, and on that is kept in a closed cylindrical box fancier apparatus. Over there the stress is applied from the all direction, like from of the periphery of that cylindrical sample, and so the stress is acting, if this is a cylinder and stress is acting from all direction, so it is a real life condition as well, because when we take a soil, when we think about the soil from our ground at any cross section, we see soil is surrounded by soil itself, and that is applying the soil particle and its adjacent soil particle apply the pressure on each other. So that actual condition we try to develop in the laboratory during the triaxial test. And apart from that, the stress from the vertical direction is also applied on that, which is applied in the real life situation when any construction work is over there above that soil mass. So in the triaxial test, that is one of the most important aspects that take care of the practical implementation, the practical implementation of those things. Okay, so I think so up to this everything is clear. Now I will again move ahead. That is, it trial test offer a better application of in situ condition, exactly what I have discussed, and it also help in understanding the soil behavior under the more complex loading conditions. Right? Now we talk about the Bayesian test. As I have told earlier as well that we will talk about the three of the test in the detail. So when we talk about the Bayesian test, so the Bayesian test for the soft and sensitive soil. Because in this test, what we do, we insert our instrument in the field and we rotate, we provide a torque, and then after that there is a interrelation like t by pi d square into h by 2 into d by c square. H is the height of that vein, d is the dia of vein, and so and t is the torque which we apply. We will talk about that. Nothing to worry, we will talk about that in the upcoming classes. So the vein shear test is also one of the most important tests. With over here we can also find the help with this sensitivity is also calculated. So that is the different aspects. We will talk about that as well. So the vein shear test for the soft and sensitive soil only, because if the soil is stiff, we couldn't apply the torque, our specimen doesn't move, so we are not able to apply our interrelation to find the shear strength. And it is application in laboratory and field setting, including the offshore environment, because there is a laboratory apparatus and the field apparatus both for this test to take place, and it is to measure the in situ shear strength in the difficult sampling situations. When we talk about the next test, which I have shown earlier, is like the torque shear test. So it overcomes the limitation of the shear box test. at the higher shearing level. It includes the torsion test as a method to apply the high magnitude of strain to the sample and its significance in studying the material behavior at the elevated shearing levels. Okay, when we talk about the flat jack test, the use of the flat jack test in the rock mechanics for the foundation design, it has the relevance in accessing the stability and the strength of the rock strata. The application of the flat jack test is a design of the hydroelectric power plant structure. So these are the not that much important tests. Yes, the penetration test is a little bit important because it is also one of the tests which we perform in average soil report. As I have discussed this during my first session that the in every laboratory test some of the in every field report some of the information is mandatory. Over here these value of the standard penetration test or the SCPT test is also there. So the penetration test is a method to assure the substrata worthiness for the foundation. Different type of penetration tests including SPT and SCPT are performed and these tests provide the information about the shear strength properties of the materials. Okay. I think so up to this clear. Now we talk about the method of shear strength determination. We will discuss the two of the tests that is the direct shear test and the triaxial test. So before moving ahead, we will take a small 5 minute break and afterwards we will move forward. I think so that will be good. So over here I will stop. So we remain in the meeting. We will start after 5 minutes. Hello. Okay. 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 We will go forward. We are talking about the method of the shear strength determination. So different methods are there. Today we are going to talk about the direct shear test and triaxial test, and up to which we will go, and then we will sum up the today's session. And in the next class, we will discuss about the vein shear test as well, in addition to the direct shear test and triaxial test problems. And on the basis of that, we will understood that what is the direct shear test, triaxial test, vein shear test, which are the some of the most important tests apart from the penetration, as we talked about the standard penetration test. So we will go one by one in that direction, and we will understood that what are the things which we need to grasp. Okay. So the two methods is like the direct shear test and the triaxial test. Now we will see what is the direct shear test. Okay. So the test is carried out on a soil sample confined in a metal box. As you may be aware about this or may not be, so I will explain everything. So this test is carried out on a soil sample confined in a metal box of solid cross sections, which is split horizontally at a mid height. So this is one of the most important limitation of the direct shear test is that it has a predefined failure plane. Basically, it has split horizontally at the mid height, so the failure takes place when the soil gets filled. It will fill from that section only, and it is not the necessary condition when we talk about the soil in the field that we already know that it's filled from this plane only. But in the direct shear test, this is one of the limitation that it needs to be carried out in the metal box, which has a square cross section which is split horizontally at a mid-height. Small clearance is maintained between the two half of the box. The two half of the box which split horizontally. There is small clearance is also maintained between the two half of the box, and soil is sheared along a predetermined plane by moving the top half of the box relative to bottom half. How we perform? We apply some amount of load, and afterwards we start increasing the load on that, and at some load it gets filled. So when the failure takes place, at that what much load is the shear strength, because we know that as I have explained this example again and again, like suppose somebody has the strength of 100 kilonewton. If you apply 99 kilonewton, there is no change takes place when we apply the 100 kilonewton. It's on the verge of failure, but when we apply 100.1 kilonewton, it gets failed surely. So that concept will be applicable over here also. And the box which we talked about of the metal cross section of the square cross section has the size of 60 mm into 60 mm in general. Okay, you can see one of the this diagram which represent the typical shear box. Okay, I think so. You can able to see that. So over here, the normal load is applied, and in this section, the box is allowed to move in the horizontal direction, and you can see the cross section over here. I give me a minute. I will try to show you. Okay. You can see over here, uh, this section of the figure is represented over here. So this is the section where the when the sample get moved, you can see this cross section over here. The predefined section is there from which the failure can take place. So you need to be aware about this, that this is one of the limitations from where failure could be take place. Okay. Now we will discuss about the condition. What are the conditions that is required to perform this test? So if the soil sample is fully or partially saturated, performed perforated metal plates and the porous stones are placed below and above the sample to allow the free drainage. Because if it is the saturated partially or fully, there is a drainage condition need to be provided in order to perform the test in the actual condition. So if the sample is dry, the solid metal plates are used because no perforation is allowed, needed over there because no water is going to flow out because there is no water there. And a load normal to the plane of the shearing can be applied to the soil sample through the lid of the box. Now, when we talk about the taste on a sand and a clay, the taste on sand and gravels can be performed quickly and are usually performed dry as it found that the water does not significantly affect the drain strength. And for clay, the rate of shearing must be chosen to prevent the excess pore pressure building up. Okay, when we talk about the procedure of the test, see, the procedure of test is also here. So the edge of vertical, when we talk about the procedure of the test, as a vertical normal load is applied to the sample, the shear stress is gradually applied horizontally by causing the two half of the box to move relative to each other. As you can see in the picture on your screen, the two half by as a vertical normal load is also applied over there. You can see in the image, is applied to a sample, the shear stress is gradually applied horizontally by causing the two half of the box to move relative to each other. The each other. The shear load is measured together with the corresponding shear displacement, and the change of thickness of the sample is also measured. The number of samples of the soil are tested each under the different vertical loads. The vertical loads are changed and the value of shear stress at failure is plotted against the normal stress of each of the test, provided there is no excess pore water pressure in the soil, the total and the effective stress will be identical. From the stress at failure, the failure envelope can be obtained. And when we talk about the failure envelope, the stress up to which and it lie below the failure envelope, it will not going to fail, but is the stress which is applied touches that failure envelope or go above, the failure takes place instantly. Okay, I think up to there clear. Okay, now we will talk about the advantages. There must be some advantage and there must be some disadvantages of this test. As I have talked very earlier, and some of the disadvantage like the predefined failure plane for this test. So first of all, we discuss the advantage and then we discuss the disadvantage for this test. Okay. So it is a easy test uh, mm, for the sand and gravels. Okay. And the large sample can be tested in a large shear boxes as a small sample can give the misleading result due to the imperfections such as the fractures and fissures or may not be truly representative, and the sample can be sheared along the predetermined planes when the shear stress along the fissures or the other selected planes are needed. Okay, so these are some of the advantage. When we talk about the disadvantage, also we talk about the three of the disadvantages. Like the failure plane is always horizontal in test, as you can see from we have seen from the image, the plane is horizontal over there, and the soil section always fill. in that direction only after the application of the normal load and the soil sample it gets start moving. So this may not be the weakest plane, and there is the 50% probability or maybe 60-40% probability like the plane through which we are going to fill the soil is not the weakest plane. So suppose we have the predetermined plane for the failure, and suppose that plane is the most strongest plane, so the strength which will come for that plane is the much higher for the other sections. If we cut the soil from any other place and we see the strength there might be less what we have found from that section which is predetermined for us. So in that case what happens, there is a problem over there. When I talk about problems, so you think what is the problem? There is a problem like at that section the strength which we reported is the higher what for the other section. So that section is not the critical section. So in actual field condition, at the soil gets filled maybe below that stress, below that stress level what we say the strength for the soil. So that is one of the reason. It is one of the limitation. Is like it may not be the weakest plane in the sample. Failure of the soil occur progressively from the edges toward the center of the sample. And we talk about the second disadvantage. There is no provision for measuring the pore water pressure in the shear box, and so it is not possible to determine the effective stress from the undrained test, and the shear box apparatus cannot give the reliable undrained strength because it is impossible to prevent the localized drainage away from the shear plane. So over here we couldn't differentiate about the C dash, phi dash and C phi. So this is one of the most important limitations which get eliminated in the tri-axle test when we move ahead with the tri-axle test. So okay, now it's time to okay, now time to move for the tri-axle test. And what do we mean by tri-axle test need to be understood by us. Okay, okay. So in the tri-axle test is carried out in a cell on a cylindrical soil sample having a length to diameter ratio 2. The size of the triaxial test is usually 76 mm into 38 mm. As it has been already reported, the sample having a length to dia ratio 2. So here the 76 mm is the height and the 38 mm is the dia. And the another sample size is the 100 mm into 15 mm. Over here as well, the height of the soil sample is 100 mm and its diameter is 15 mm. In the triaxial test, three principal stresses are applied on the soil sample, out of which two are applied through the water pressure inside the confining cell and are equal. The third principal stress is applied by loading ram through the top of the cell and is different to the other two principal stresses. A typical triaxial cell could be seen in our next slide. You can see over here a typical triaxial cell is shown. Over here you can see the cell pressure, the pore water pressure, or maybe set to back pressure and the volume change all are represented. The deviator stress is also represented. Okay, I have talked about the sample which is of size maybe 100 into 50 mm square or 76 into 38 mm square is kept in the triaxial apparatus over there. The two stresses is applied like the confining pressure sigma 3 is applied all around with the help of water. So you should understand that how the stress work. When it escape in the sample over here, the water is fill into it and the stress is applied from the all direction, that is said to be the sigma 3, and afterwards the deviatoric stress is applied from the top, that is said to be deviatoric stress, which is equal to sigma 1 minus sigma 3 from the interrelation, that is sigma 1 minus sigma 3 equal to sigma d, as sigma 3 is already known, which we are applying through the confining pressure through water. So sigma 1 could be calculated, as we also know how much deviatoric stress is applied on that sample. So sigma 1 minus sigma 3 equal to sigma d. So sigma 1 equal to sigma 3 plus sigma d. That much the understanding of this problem. And I think so at this point of time, the things are clear for everyone. Okay, now we will move for the test procedure. Okay, so what are the test procedure? Yes. Okay. Give me- Okay. We are talking about the test procedure. As we have discussed the procedure of the direct shear test, we also need to understand the procedure of the triaxial test. The soil sample is placed inside a rubber which is still on the top cap and bottom pedestal by removing hot test with the pore pressure measurement. The porous discs are placed at the bottom and sometimes at the top of the specimen. The filter paper drain may be provided around the outside of the specimen in order to speed up the consolidation process. Pore pressure generated inside the specimen during the test can be measured by the means of pressure transducers. Over here, there is a special provision that we could calculate everything, that is how much the pore water pressure get developed. So in this, we could able to find all the parameter like the effective strength parameter and the total strength parameters. Okay. Now we talk about the triaxial compression test consisting of two stages. The first stage is a stage in which a soil sample is set in a triaxial cell and a confining pressure is then applied, and that confining pressure is nothing but sigma 3. In the second stage, the additional axial stress, also called the deviatoric stress, is applied, which includes the shear stress in the sample and the aerial stress is continuously increased during the sample phase. During both the stages, the applied stress, axial strain, and the pore water pressure or the change in sample volume can be measured, as we have also discussed, seen from the previous triaxial diagram. Over every gauge is implemented over there. Okay. Okay. Now we talk about the some of the test type which is used in the triaxial test. So the first is the unconsolidated untrained test. In this, the cell pressure is applied without allowing drainage, then keeping the cell pressure constant. Deviator stress is increased to the failure without drainage. So I will explain this in the another manner as well. You can see, as the name suggests, unconsolidated untrained. So in the both stages, the water is not allowed to flow out. As first of all, in the confining stage, sigma 3 is applied and the uh, water valves are remain closed. Afterward, in the second stage, when the diabetic stress is applied up to failure, the valve to escape out water remain closed and the unconsolidated undrained test get performed. Okay, over here you can see we are able to form the Mohr circle diagram as well on the basis of this or the Mohr Coulomb failure envelope from which we could identify the cohesion and angle of internal friction. Okay, no problem. Now we talk about the consolidated drain test. In this test, the drainage is allowed during the cell pressure application. Then, without allowing the further drainage, the deviatic stress is increased, keeping the cell pressure constant. Okay, the things is very much understood. Like drainage is allowing during the cell pressure application. Basically, in the first stage, in the confining stage, drainage, the valve to escape water remain open when the stress is applied over there, and then without allowing the further drainage, after that the valve is get closed and the stress is applied up to failure. Okay. Mm, give me a minute. I will go back. Okay. Now I will move ahead. You can see we have talked about the unconsolidated, untrained trace, consolidated, untrained trace. In the consolidated untrained trace, in the first stage, the water bed remain open, the drainage is allowed, and in the second stage, the drainage is closed, and after that, the um, Deviated stress is applied. Now we move to the third test, that is consolidated drain test. And this is similar to CU test except that the deviatic stress is increased, drainage is permitted during the second stage as well as of the first stage, and the rate of loading must be slow enough to ensure the no excess for water pressure to develop. Now we talk about that which test is suitable for what type of soil or which test amplify the relations. So when we talk about UU test, we can perform it on the both type of soil, like the clay and sandy soil. But when you talk about CT test, yeah, you say clay require large time for drainage and the water flow out very slowly. As you also know, when we talk about the clay have the large number of small particles, large number of small particles. So the waters are inside that, and to flow out, it takes large time. So the CD test implicate that condition. Okay, so that's not the factor that we will discuss in the subsequent uh, things. Okay, so now we talk about significance. As we already said, whenever we talk about any test, any procedure, we talk about its importance or significance. We talk about the advantages, their disadvantages. So we are able to figure out our develop our understanding at the point of time. Okay, so we are talking about the significance of the triaxial test. Then we will move to the advantages over the direct shear test. Afterwards, we will take some of the real life example in which we calculate the values and interrelate those values for our understanding. Okay, no problem. I think so. Okay, so I am talking about the significance. The first stage simulates in the laboratory the C2 condition that the soil at the different depth is subjected to different effective stress. Afterwards, the consolidation will occur if the pore pressure which develops upon the application of the confining pressure is allowed to dissipate. Otherwise, the effective stress on the soil is the confining pressure or the total stress minus the pore water pressure which is existed in the soil, and I have discussed this point very often at many point of time, at not many point of time, at one point of time in the starting when we are discussing the relation about S equal to C plus sigma tan phi over here. I have clearly stated this point that the value of the pore water pressure need to be subtracted from the total stress to find the effective stress over there. You develop the interrelation between those things. Okay, so I will read it again. Like the first stage simulates in the laboratory, the in situ condition where the soil at different depths is subjected to the different effective stress, and afterwards the consolidation will occur if the pore water pressure which develops upon the application of the confining pressure is allowed to dissipate. Otherwise, the effective stress on the soil is the confining pressure or the total stress minus the pore water pressure which exists in the soil. When we talk continuing the significance during the shearing process, the soil sample experiences the axial strain, and either the volume changes or the development of the pore water pressure occurs. The magnitude of shear stress acting on the different plane in the soil sample is different. When at some strain, the sample faces the limiting shear stress on the failure plane, which is called as shear strain. Exactly. Now we talk about the advantage over the direct shear test. The soil samples are subjected to uniform stress and strain, and the different combination of confining and the axial stress can be applied. The drained and undrained test can be carried out. The pore water pressure can be measured in the undrained test, and the complete stress strain behavior can be determined. Okay. Now, when we talk about the difference or the many advantages which we are getting with the help of direct shear test above the with the tri-axle test above the direct shear test, we will see that the stress strain is uniformly acting as we have seen over there. The load is applied from the vertical direction. How the stress and strain is uniformly acting? As we made the sample, we kept in the fluid box, and in the confining stress is applied from the all directions very uniformly. That's why the stress and strain is subjected in the uniform manner. There are the different combination of the confining and the axial stress can be applied, as we have seen the UU, CU, and CD, the different combination, different drainage condition at all point of time could be applied. When we talk about the pore water pressure can be measured in the undrained test, as we know if the pore water pressure could be measured, we are able to make the decision to find the total stress parameter and the effective stress parameter. The complete stress strain behavior can be determined. Okay, now we will talk about the total stress parameter. See, when we talk about the total stress parameter, you can see in UU test, that is the unconsolidated and unconfined unconsolidated test, the value of phi is found to be 0. Why? Maybe a question arises. Like when we apply sigma 3 and we apply the deviatric stress, it will fail at a specific section and a Mohr circle test get formed. Afterwards, we change our sigma 3 and we again apply our Deviating stress, and after that the value remain the same circle of same radius in same fashion. Again we perform the test, and you can see the Mohr circle form in this way, in this fashion, and when a tangent is put above that, we are able to find the cohesion intercept on the tau axis, and the value of angle of internal friction is equal to angle with the horizontal axis, which is found to be here 0 degree. So the value of cohesion is said to be Cu, which is the intercept on the vertical axis here axis, and the value of angle of internal friction is said to be 0. So this type of UU test, this type of Mohr circle is going to form. When we talk about this, the also Mohr circle of the UU test plotted in terms of total stress have same diameter. If you plot in the term of total stress, it will have same diameter. When you plot in the term of effective stress, things get changed. And the failure envelope in is a horizontal straight line, and hence phi UU equal to 0, and it can be represented by the equation that is tau f equal to Cu, that is equal to sigma 1 minus sigma 3 by 2, as the phi equal to 0. So tau equal to C plus sigma, and tan phi equal to 0. So tau equal to C. That's why this relation has been mentioned over here. Okay. Now when we talk about CU and CD test, over there the Mohr circle get are formed of the different diameter. So sigma 3 sigma 1 in the test 1 is represented, afterwards sigma 3 sigma 1 in the test 2 is represented, and a tangent is drawn from those two circles, and the intercept which get formed on the y-axis is said to be cohesion, and the angle which it made with the horizontal axis is said to be angle of internal friction. When we talk about this for the test involving drainage in the first stage, when the Mohr circle are plotted in terms of total stress, the diameter increases with the confining pressure. The resulting failure envelope is an inclined line with and intercept on the vertical axis. It is also observed that CUU is not equal to CCD and phi CU is not equal to phi CD. It can be stated that for the identical soil samples tested under the different triaxial condition of UU, CU and CD test, the failure envelope is not unique, because when we talk about total and defective, the things get changed. So the Mohr circle also get changed for the total and effective condition. When we talk about the effective stress parameter, that is C dash and phi dash, if the same triaxial test result of UU, CU and CD test are plotted in term of effective stress, taking into the consideration the measured pore water pressure, it is observed that all the Mohr circles at the failure are tangent to the same failure envelope, indicating that the shear strength is a unique function of sigma. Okay, so over here you can see when we talk about the effective shear parameter, C dash phi dash could be found in this fashion. The different Mohr circles are formed, tangentially drawn, and the intercept on the y-axis is said to be the cohesion, and the intercept on the and angle with the sigma axis is said to be angle internal friction. Okay, I think so. Okay, now we can see that the failure envelope is a shear strength envelope, which may then be written as tau f equal to c dash plus sigma dash tan phi dash. where C dash is the cohesion intercept in term of effective stress and phi dash is the angle of shearing resistance in term of effective stress. If sigma and dash is the effective stress acting on the rupture plane at failure, the tan is the shear stress on the same plane and each. Therefore, the shear strength, the relationship between the effective stress on the failure plane is sigma 1 dash equal to sigma 3 dash into 1 minus 1 plus sin phi by 1 minus sin phi plus 2c dash root under 1 plus sin phi by 1 minus sin phi. It can be said in the other way as well. We can say sigma 1 dash equal to sigma 3 dash tan 45 plus phi by 2 plus 2c tan 45 plus phi by 2. So, when you use geotrigonometric skill to convert the 1 plus sin phi by 1 minus sin phi, you find tan 45 plus phi by 2. Similarly, when you convert use your trigonometric skill to find the root under 1 plus sin phi minus 1 minus sin phi, you find tan square 45 plus phi by 1. That is the most important equation for the triaxial test to find the shear strength parameter when the different interrelation between the C dash and phi dash has been given. Okay, now we move forward. You see the pore water pressure parameter. And what is the pore water pressure parameter? That is we are going to discuss. The difference between the total and the effective stress is simply the pore water pressure. As we have discussed this earlier as well, that is the difference between the total stress and effective stress is the pore water pressure. As we know, effective stress is equal to total stress minus pore water pressure. So that is the case. Consequently, the total and effective stress Mohr circle having the same diameter and are only separated along the sigma axis by the magnitude of the pore water pressure. It is easy to construct a series of total stress Mohr circle, but the inferred total stress parameter have no relevance to the actual soil behavior. In principle, the effective strength parameters are necessary to check the stability against the failure of any soil construction in the field. To do this, the proper water pressure in the ground under the changed loading condition must be known. And in general, as we are not aware about that, so that is one of the contradictions. Okay, okay. In a undrained triaxial test with the pore water pressure measurement, this is possible and the effective stress can then be determined. Alternatively, in the drained test, the loading rate can be made sufficiently slow so as to allow the dissipation of all the excess pore water pressure. For the low permeability soils, the drainage will require longer times. In undrained test, the general expression relating the total pore water pressure developed and the changes in the applied stress for both stages is delta U equal to delta U1 plus delta U2 and equal to B into delta sigma 3 plus B into A into delta sigma 1 minus delta sigma 3 equal to B into bracket main delta sigma 3 plus A into delta sigma 1 minus delta sigma 3, where delta U1 is the pore water pressure developed in the first stage during the application of the confining stage delta sigma 3 and the delta U2 equal to pore water pressure developed in the second stage during the application of the deviator stress delta sigma 1 minus delta sigma 3 and B and A are Scampton water parameter. So when we actually perform the experiments actually perform the laboratory test, these parameters are very much important because on the basis of value of Skempton parameter B, that is either 0 or 1, we will understood the soil is in the saturated or in the unsaturated condition. So it is very much important that understanding of the parameter and defining the formula of the any interrelation to solve the problem is not that much important as you understand the basic of that point. Because if the understanding about the B and A is not clear up to that extent, one can miss the flow regarding the different skill set. Okay, when I talk about the skill set, we see that actually during the performing in the lab, you have all the theoretical knowledge, but the practical implementation get missed out, then it will lead to a greater problem. Okay. The parameter B is a function of the degree of saturation of soil equal to 1 for the saturated soil, it is already said by me, and equal to 0 for the dry soil. The parameter A is also not constant and it varies with the over consolidated ratio of the soil and also with the magnitude of the diabatic stress. And A and A bar are the two more parameters also there as we see, but that's not the problem as the interrelation bifurcated those things, the relation which I have shown in the previous slide. So you can see the parameter is also not constant and it varies with the over consolidation ratio, that is the stress applied in the past by stress applied at the present. Um, and also the magnitude of the diabetic stress, the parameter is also get varied. The value of the A at failure is necessary in plotting the effective stress number supply. Okay, up to this clear? Okay, let's go. When we talk about the behavior of the saturated soil sample in the undrained dry axial test, in the first stage, increasing the cell pressure without allowing the drainage has the effect of increasing the pore water pressure by the same amount. Thus, there is no change in the effective stress during the second shearing stage. The change in the pore water pressure can either be positive or negative. Okay, that's not the difference. For the UU test on the saturated soil, the pore water pressure is not dissipated in the both the stages. That is delta U equal to delta U1 plus delta U2. And for the CU test or the saturated soil, the pore water pressure is not dissipated in the second stage. That is delta U is equal to delta Q2 because in the CO test on the saturated soil the pore water pressure not is dissipated in the second stage, so delta U the pore water pressure whatever we develop in the second stage only, so the delta U is nothing but delta U2. Okay, clear? I think so. Now I will talk about the stress strain behavior of soil. When we talk about the sand are usually seared under drained condition as they have relatively higher permeability. This behavior can be investigated in the direct shear or the triaxial test. The two most important parameters governing their behavior are the relative density ID and the magnitude of the effective stress sigma dash. When we talk about the relative density, it is normally presented in the term of percentage and which has been given as E max, that is the density, maximum pore water pressure, Emax minus E my E by Emax minus E mean, where E is the void ratio. So Emax is the maximum void ratio, E minimum is the minimum void ratio, and the on the E is the void ratio in that standard test condition, that is laboratory condition. So on the basis of that, the calculation of the relative density is done. Okay, no problem. I think so. The relative density also given in the term of density. So that is gamma d minus gamma d mean by gamma d max minus gamma d mean multiplied by gamma d max by gamma d into 100. So the percentage could be found. Over here, the gamma D max and gamma D mean are the maximum and minimum dry density, and gamma D is the current dry density. Sand is generally referred to as a dense if the relative density is greater than 65% and for the loose it is less than 35%. You can also see the variation of diametric stress with the axial strain, volumetric strain, and the void ratio is also shown in this image. And one more point I will try to refer from here is like I am talking about the influence of the relative density on the behavior of saturated sand and can be seen from the plot of the CD test performed on the some effective confining stress. There would be no included pore water pressure existing in the cell. Okay. Now, when we talk about that image in succession, you see for the dense sand sample, the deviating stress reaches a peak at the low value of the axial strain and then the drop down. Whereas for the loose sand sample, the deviating stress build up gradually with the axial strain. The behavior of the medium sample is in between. The following observations can be made. All the samples approach the same utility condition for the shear stress and the void ratio, irrespective of the initial density. The denser sample attain a higher peak angle of shearing resistance in between. Initially, the dense sample expand or dilate when the shear and initially the loose sample compresses, which is represented in the diagram in the last slide. Now we will solve the example problem. So you can see the first example problem in front of you. Sorry. Okay, I think so now slide is visible. Yes. Okay. See. So over here, the question is there. A UU test is carried out on a saturated, normally consolidated clay sample at a confining pressure of 3 kg per cm square, and the deviatric stress at failure is 1 kg per cm square. Now the question is to determine the total stress strength, totally stress strength parameter, and the second part of the problem is if the identical sample is tested at the confining pressure of 4 kg per cm square, what will be the vertical stress at failure? So you can see over here, we are aware about this image, that is the cohesion is the intercept on the y-axis and sigma 1 and sigma 3 like this phi equal to 0. So in the first problem, part of the problem, sigma 3 is given as 3 kg per cm square. So sigma 1 minus sigma 3 is going to be 1 kg per cm square, and from the plot in the last page you can see phi uu equal to 0. So cuu equal to sigma 1 minus sigma 3 by 2, that is 0.5 kg per cm square. And I think so you have understood this concept from the definition over here when we are discussing the uu test over there. Sorry, the same thing is presented. Okay. Now, when we talk about the second part of the problem over here, sigma 3 is 4 kg cm square. The question is there if the confining stress is 4 kg per cm square. So, in this test, UU test is the identical sample yield the Same failure diabatic stress. So sigma 1 F minus sigma 3 F at all the confining pressure. Therefore, the vertical axial stress at the failure is sigma 1 F equal to 4 plus 1, that is 5 kg per cm square. I think so thing will be clear. Now we will take the second question very quickly, and you can see the question is said that the result of the test conducted on the two saturated clay sample are given. Determine the shear strength parameter. So the sample 1, the confining pressure is 4 kg per cm square, and the axial stress at failure is 6.8 kg per cm square. The pure water at failure is 3.8 kg per cm square. Similarly, for the case 2, 6.3, 9.3, and 4.8 respectively are the confining axial and the pore water pressure at failure. So, to solve this problem, first of all, you see this image, and then you can see sigma 3 equal to sigma 3 minus sigma UF, and sigma 3 is given as 4.8, and the value of pore water pressure is 3.8. So sigma 3 effective is 1, and sigma 1 effective is sigma 1 F minus UF is 3. Or similarly for the sample 2, sigma 3 effective and sigma 1 effective is 1.5 and 4.5. When we plot this 1 3, you can see the first Mohr circle get formed, sigma 1 and sigma 3, sigma 3 and sigma 1 as 1 and 3 respectively. Similarly for the second case 1.5 and 4.5, then a tangent is drawn and tangent is passing through the center. So the value of cohesion over here is going to be 0, and the angle which it made with the horizontal axis is found to be 30 degree. So the value of cohesion and angle of internal friction is found to be 30 degree. So this question is very much simple and could be solved with the help of Mohr circle. So this is one of the most important understanding you develop. So we have solved the two numerical problems up to here. Now we will move ahead and we will see that what we understood in the today's lecture, because we have gone across the entire sessions. Some understanding you must carry out from this session. So what we discussed, first of all, in the start of the class, we have a quick recap of the last class, in which we discuss very quickly in the first 5 to 10 minute time that what we have discussed during the last lecture. So we come at the output that during the last lecture we have come across the various aspects of the shear strength. We understood the shear strength. After that, we come to know the different things about the triaxial, about the testage in a very brief. After that, we move to the Mohr circle, how we found the how we solved the problem of the Mohr circle. And in the last class, as I remember, I have given the sum of the homework to solve the same problem which I have, four problem which I have provided in that slides, and also some solve some additional problems from the books, and I also give the reference of the books as well at that places. Now today the main aspects which we understood is the direct shear test and the tri-axial test, but some more detail is still due, which we will take in the subsequent classes. So the understanding of the direct shear test and the tri-axial test is developed for us. Now the some question you need to answer if the lecture has gone in the right way. So first of all, the simple problem: what is shear strength? It is also there in the last class. So please write this, and after that write the detailed procedure of the direct shear test, because the procedure is discussed during this class, and same for the tri-axial test. And if you are the college going student, so please try to perform these two tests if the apparatus everything is in order at your institutions. So because the theoretical knowledge is one thing, when you go to perform that test in the laboratory, you will get the more idea, you will get some doubts as well, which you can ask in the next class, and I will try to answer those problems. And one more important thing, that if the equipments or anything are missing or not found in order. If you are not the college going students, if you are the working professional, try to see its demonstration on available on YouTube through the various recognized universities and the NPTELs or NCTEL. There is a thing over there you can see the demonstration. So you will get a practical idea because with the help of images I try to show everything, but this might be something that which concept could be missed. If you see its demonstration as well, you will get a better idea about that. And one more thing that solves some problem, as at the end of the class we have solved three or four problems. So try to solve the similar problems at your home and try to revise the previous concept, revise this entire concept, go through the lectures, and afterwards come to the next class, and whatever the questions, whatever be your doubts, you can ask me, and I will love to answer those questions. These are the some reference book I am mentioning over here. You can go across these books. These books will provide you some idea that what are the problems over there. You can solve the problems from these books, and this will be helpful for you. So with this, I will sum up the today's session. I will end the today's session. Wish you a happy weekend, and with this, I will sum up the today's session, and I will wish you all the best. Thank you for your patience to be in the meeting. Thank you very much.